per length, that is. If I take the expectation throughout this expression, I can write this, sum over x, p of x minus log p of x, less than or equal to the sum over x, p of x, L of x, less than or equal to sum over x, p of x minus log p of x plus 1. Now, this is what? This average length, L of C. This is what, if I take, maybe I can take that minus inside. This is entropy. So entropy, less than or equal to L of C, that's what we would expect because that's true of any prefix code. The other side expresses the penalty, as I mentioned. So this is, I can break this up into, take this up here, sum over x, p of x, log 1 over p of x, that's the first term, plus sum over x, p of x. This is entropy, and this is what? Sum over x of p of x is 1. So h of x, the average length, if I pick these lengths, if I pick a code with these lengths, is sandwiched between entropy and entropy plus 1 bit. Okay. At first, that seems great. I mean, the maximum penalty for using a prefix code is 1 bit. That's wonderful. Until you consider the following kind of source. So let's say we have, let's say the source, x, is binary. So in other words, instead of, in fact, to reduce confusion, remember we're encoding with binary, and up till now I've been using A, B, C, D, and so on with my source. Let's say that the source just has 2 letters, A, B. Let's say A, probability of A is something very close to something very close to 1, and the probability of B is 0.01, 1 minus that. The entropy of this source is 0.99 log 1 over 0.99 plus 0.01 log 1 over 0.01. The entropy of this source is very, very small. I didn't bring a calculator with me, but I'm going to estimate this. This term, 1 over 0.99, is approximately equal to 1. So this term is approximately equal to 0 because log 1 is 0. 0.01 log, this is basically log 100. Any ideas on what, pardon me?
Close to 7, I guess.
Close to 7, exactly, because log 128 equals 7. And log 64 equals 6. So let's estimate this at about, I don't know, 6.5. So that's 0.065. So let's say this is not exactly 0. So let's approximate this as 0.07. Now, what does this formulation suggest? If I take this approach, ceiling of minus log p of a is equal to ceiling of minus log 0.99, which is equal to, well, I don't even need to calculate this. I know that this will be something slightly less than 1. Excuse me, something slightly greater than 0. My apologies. Something slightly greater than 0. So therefore, I'm going to encode this with 1 bit. And ceiling negative log p of b is equal to ceiling negative log 0.01. And as we argued a second ago, this is probably, the ceiling of negative log 0.01 is probably something like 7. Actually, it is 7. So my average length of this code would be 1 times 0.99 plus 7 times 0.01, which is 0.99 plus 0.07, which is equal to 1.06, which is pretty far from what I estimated the entropy to be, which is approximately 0.07. It's within the bound. It's within the bound that I said a second ago. I said my maximum penalty is 1 bit per source letter, and that's exactly what we have. If I add 1 to this, I get 1.07. So we're paying pretty close to the maximum penalty here. But compared to the entropy, the penalty is enormous. And furthermore, I can think of a trivial code that does actually better than this. What would that be? 0 and 1, exactly. So I could say A is 0, and B, I need not express B with 7 letters. I can simply say B is 1. And the average length of this code is 1. So, although 1 bit per source letter doesn't seem like a huge penalty, there are circumstances where it is kind of overwhelming. And this is one of them. But there's a trick. There's a trick you can use.
Excuse
Yes.
me, could you repeat what you've done about the 0 and 1?
Right, so what does this imply? This implies that I have the code that I suggested that I use assigns 1 source letter to A, because that's the ceiling of this probability. This is actually a very small number, but the ceiling of that small number is 1. And I assign 7 binary bits to B. So in other words, this code, I suggest that this should be 0, maybe, and this should be 1, 1, 1, 1, 1, 1, 1. Now, I can obviously do better than that by doing that.
Yes, that's clear, but what does this show?
What this is showing is that although so this is as good as my code can do.
From the previous equation?
Yes, from the previous equation. This is as good as I can do. So my penalty is 1 bit per source letter. So it may seem like 1 bit isn't very much, but this is an example illustrating that in fact, 1 bit per source letter can be enormous.